I'm Sophia Vishnia, and this is my Lab 4 report. So in Lab 4, we used the FET circuit simulation, and so we played around with concepts like changes in potential across batteries, resistors, and wires. And so we used Ohm's law to calculate resistance and current in series and in parallel, and we also used the node rule and loop rule. And then we also played around with charging and discharging capacitors and measuring the time dependence in the current flow. So basically, as the capacitor is charging or discharging, the amount of current that's flowing decreases exponentially over time. Okay, so in the first part of the lab, we just set up a basic series circuit with 2 batteries and 2 resistors, and so we were trying to figure out the amount of current that's flowing through this circuit, both with ammeters and just by calculating it. So using Ohm's law and the equivalent resistance of these 2 resistors in series, I calculated the current to be approximately 0.02 amperes, and that's exactly what the ammeters measured. Okay, so then in the second part of the lab, we quote-unquote broke the circuit. So instead of one of the ammeters, we inserted a voltmeter. And so the voltmeter is a very high resistance element, so it's kind of hard for current to flow through it. And so by the loop rule, the total change in potential across the circuit has to be 0, and the batteries have a +3 change in potential, so you should have a -3 change in potential across the voltmeter, and then no current will flow past the voltmeter, so the ammeter will read 0. Okay, and after that, so we put the circuit back together, and we measured the changes in potential across different elements like batteries, wires, resistors, and ammeters. And so to the left you can find the changes in potential. So across the battery we have a +3 volt change in potential. Then across all the wires in the ammeter there was a 0 change in potential because we're assuming that they carry no resistance according to Ohm's law. And then across the 2 resistors, you see some decrease in potential. Like across the first resistor, you have a -0.959 decrease, and across the second resistor, you have a decrease of -2.041 volts. All right, and after that, we set up a parallel circuit. So we basically set up the circuit with the 2 batteries and the 2 resistors, except this time we also hooked up an additional branch of the circuit that goes around the resistor and has an ammeter in it. Now the ammeter has no resistance, so naturally the current would want to flow down the second branch through the ammeter and just completely bypass this 100 ohm resistor. So this decreases because the current never really goes through this branch with a 100 ohm resistor. The total resistance of the circuit decreases, which increases the total current flow. So now, as you can see, the new ammeter readings are 0.06 amps instead of 0.02. Okay, and finally we played around with charging and discharging a capacitor. Okay, so we placed a battery and a light bulb and a capacitor. So initially the current flowed, but then as the capacitor got charged, the voltage difference was just too great for current to flow through the capacitor, so the current stopped flowing. And so we measured the amount of time that it would take to do this, depending on the resistance of the light bulb. Okay, and so it took like 8 seconds for the capacitor to charge with the 10 ohm light bulb and 11 seconds with the 20 ohm light bulb. And we repeated the same, except we removed the battery and saw how long it would take the capacitor to discharge. With a 10 ohm light bulb, it took it like 7 seconds, and with the 20 ohm light bulb, it took like 11 seconds, which is exactly twice the length that it took to discharge the 10 ohm light bulb. Okay, and finally we explored like the time dependence between current flow and, between voltage and time. And so we calculated the RC value of the circuit to be 6, both from the slope of the graph and manually calculating it. Okay, finally for the questions, if I were doing this lab in real life, I would have the real ammeter would have some resistance, and also wires would have some resistance, so the current flow would be less. And as far as charging the capacitor, it would take a little longer because, you know, there's some resistance, but the formula actually for the capacitor implies no resistance. Okay, thank you. Have a good day.